look at this dancing fractal pattern. It looks pretty cool. It looks like every item of the of the fractal is moving around, jumping around. Looks really nice a dance. Right now in this video we'll see how we can build this. We are obviously enhancing the fractal and recursion program from the YByte Python curriculum, available at www.ybyte.in. Now, you might recall that since this is based in Turtle, when we first did Paint with Turtle, we had done, a smiley with eyes, and we had this one bonus idea where the eyes would bounce around. In fact, the idea is exactly the same over here. So what we will do here is, remember my, my fractal here goes in a certain heading. I'm going to say, let me not fix this heading to a certain number. In fact, I'll get rid of this. I'll just go and say, look, t dot set heading to a random number. Now, how do I get that random number? Well, I can just go and say random dot say rand int, say between -20 and 20. Right now, again, this is a choice, but of course I must go and import random, which I have done earlier. So I already have import random over here. So now I'm basically saying that, look, for every time a drawing is made, go and set heading to a random number. Now see this carefully. Basically, for every level, every time the drawing part is called, the heading will be random, which means when I run this, I expect each of these to be in a random orientation. We can check this when I run this code. You notice one square went in a certain direction. Every square is basically being drawn in a random direction. You can see it very clearly. There's no pattern. Each time the code comes to, let's say, this point, the drawing part of it, there's recursion going on, this drawing going on. Every time we come to the drawing part, basically, instead of setting heading based on the level like we were doing previously or to a fixed number, now I'm setting it to a random number. So what remains to be done now is basically, to take from here, to go from here to an animated version. And the way that happens is by using, a few concepts which we have seen before. First of all, we can't have the drawing of fractals taking such a long time, and that can be accomplished using the, let's say, the tracer function. So what I can do is, look, I will go and say ts is equal to t dot screen, and I will define a function called animate, let's say. So define say animate. um, you know Basically, I'm going to say that, well, when I call this animate, please clear up everything that's been drawn. Set the tracer to 0. Now remember, this is like running without screen refresh, which means the code would run, but the entire output will be shown at once, once the display is updated, right? So exactly, we've seen this before. And I'm going to just call my square function here. Let's say, minus 160 and at level 0. Now remember, this is recursive, but because the tracer being 0, when I update my function, this will be done. However, animate, I want this to run again and again, and hence I can use ts.onTimer. Now we have seen this before. Basically, on timer. So if I do ts.onTimer, it's like, the idea is that every time the time elapses, go and run the function again. So I'll just call this animate once again, at say 500. Now it means that every 500 millisecond, go and run this animate once again. And really all I need to do is to call animate once, and thereafter its cycle. You'll notice that the fractal is being drawn again and again with random numbers, and hence it looks like it is dancing around. Like I said, we have already looked at this idea when we did Paint for Turtle, so you can refer to that as well. So now when I come into my code, I just run animate once, and in fact that's all I need, because now the entire process is set in motion. Every 500 millisecond, the function square is called. That runs effectively without, let's say, screen refresh, without the tracer being updated, because my TS tracer 0. The entire fractal pattern gets formed at once, displayed, and then I call it again. So since the headings for every square is being selected randomly, it looks like each of the square is jumping around, dancing, and looks pretty cool. In fact, we can add more randomness to this. We can even move the x and y coordinates of these, so that the square also looks to be moving, let's say, horizontally or vertically a little bit along with all this. So lots of possibilities still exist, but it's the thought process, the structure of the code that is interesting. And I hope you found this interesting. In general, building activities, thinking how we can enhance them is a great way to learn programming, and it's also fun. Look at our website www.ybyte.in, because we learn Python programming through such fun activities. Take care. Thank you so much. Bye bye.